Hello everyone, my name is Elena Magallon. I'm in 6th semester of Mechanical Engineering, and today I'm going to show you how to do the worksheet number 8 with title Various Methods of Solid Meshing. The objective of this workshop is the following. Become familiar with creating a hex and a TED mesh. For this workshop, 4 elements of the same system are to be created: a hex 8, a hex 20, a TED 4, and a TED 10. Element model is to be created. This involves creating geometry for which the meshes are created. The same constraints and applied loading are used for each model. The results from a linear static analysis of each model are compared. Here you can read the problem description. And the softwares that we're going to use are Patron and Nastran. Remember to always create a new folder with the same name as your file, where you are going to save all your files. And like always, the first step that we're going to do is create a new file. Once we have created a new file, we're going to do the following. We're going to set the tolerance by clicking on Base on Model and enter 10 for the approximate model dimension. Set the analysis code, analysis type to MSC, Map Nastran, and structural respectively. Then click OK. Now we're going to import the Parasolid file. We're going to make a click on Menu, on File, and select Import. We're going to select the desired file. In this case, the name of the file is log. Then we're going to click Apply. We're going to make a click on OK. And we're going to select the ISO 1 view icon. Now we're going to rename the default group. We're going to make a click in Menu, then Group, and select Modify. We're going to make a click on Rename, and enter hex 8 for the new name and click Apply. Now we're going to create points for plane creation. We're going to make a click on Geometry and make sure that Create Point and Extract are selected. Now make sure the parametric position is set to 0.5. Turn Auto Execute off. Now we're going to shift click 3 edges, the 2 edges that make up the outer radius of the solid and one of the back edges. Then we're going to make click and Apply. Now we're going to increase the point size. Now we're going to create the first 2 planes. We're going to make sure that Create Plane and 3 points are selected in Geometry. Click on the Point 1 list and select the first point for the first plane. Then select the other 2 points. With Auto Execute on, the mouse focus changes to the next line. But remember to always turn Auto Execute off. Then we're going to click Apply. Then select next 3 points to create the second plane. And click Apply again. Now we're going to break the solid. Make sure that Edit, Solid, and Break are selected in Geometry. Now in Option, we're going to select Plane. Remember to turn Auto Execute off. Select the log Solid 1 for Solid List, and Plane 2 for Break Plane List. Then click Apply. Click Yes when message appears. Now we're going to select lower and upper solids for solid list and plane 1 for break plane list. We're going to make click and apply. And click and make a clicking yes when the message appears. Now we're going to create a group TED4 and copy geometry into it. We're going to make a click in menu, then group and select create. We're going to enter TED4 under new group name and click apply, then cancel. Make sure that transform, solid and translate are selected in geometry. And we're going to enter 0, -10 and 0 for direction vector. Then we're going to select all 4 solids in group hex 8 and click apply. Remember to turn off auto execute. Now we're going to create group TED10 and copy geometry into it. We're going to make a click in menu, group and select create. We're going to enter TED10 for new group name and click apply, then cancel. Make sure that transform, solid and translate are selected in geometry. And we're going to enter 15, -10 and 0 for direction vector. Select all 4 solids and then click apply. Remember to turn off auto execute. This is how the geometry of the 3 groups should look. Now we're going to make a click in menu, group and select post. We're going to select group hex 8 and then click apply and then cancel. We're going to make a click in fit view icon. And we're going to change the view using the icon ISO1 view. Then make sure that create point and extract are selected in geometry. Make sure the parametric position is set to 0.5 and we're going to shift select 5 edges. 4 edges that make up the lower half of the log hole and an edge at the base of the solid. Remember to turn auto execute off. This step is for creating more points for breaking planes. Then we're going to click apply. Now we're going to make sure that create, point, and arc center are selected in geometry. We're going to turn auto execute off and shift click 2 edges that make up the whole of the log. Then we're going to click apply. Now we're going to create more breaking planes. Make sure that create, plane and 3 points are selected in geometry. Now we're going to select 3 points that define a plane and it will automatically be created. We're going to make click and apply them. Now we're going to select the next 3 points for the next plane. Now we're going to break the solid. Make sure that Edit, Solid, and Break are selected in Geometry. Select bottom left portion of solid and break along plane 3. Then we're going to click Apply. Click Yes when message appears. Now we're going to select bottom right portion of solid and break along plane 4. We're going to make a click and Apply. Now we're going to break the solid. Make sure that Edit, Solid, and Break are selected in Geometry. Then select bottom right portion of solid and break along plane 4. We're going to make a click and Apply and clicking Yes when message appears. Then we're going to click Final Point and Plane. Make sure that Create Point and Project are selected in Geometry. Select the point at the bottom end of the slope edge where it intersects with the space under Point List. Then select Edge Normal to the hole under Curve List. Remember to turn Auto Execute off. Then we're going to click Apply. Now we have to make sure that Create Plane and 3 points are selected in Geometry. Select 2 points along the base of the solid and point from projection. Then we're going to make a click and Apply. Now we're going to break the solid. Make sure that Edit, Solid, and Break are selected in Geometry. Option in Plane and select Solid at bottom right for Solid List and select Plane 5 for Break Plane List. Remember to turn Auto Execute off. We're going to make a click and Apply and click Yes when message appears. Now we're going to delete solids and plane. Make sure that delete and solid are selected in Geometry. Select the 2 top solids and then click Apply. Remember to turn off Auto Execute. Then we're going to select Delete and Plane. We're going to select all 5 planes and then click Apply. Remember to turn Auto Execute off. Decrease the size of the point makers. The next step is to refit solid. Make sure that Edit, Solid, and Refit are selected in Geometry. In Option, we're going to select to 3 cubic net, and we're going to enter one of all the refit parameters. Select Delete Original Solid, and we're going to select the 5 solids. Remember to turn Auto Execute off. Then we're going to click apply and click yes when first message appears, and then yes for all when second message appears. Then we're going to display the solid labels. Increase the size of the point makers. Now make sure the transform solid and mirror are selected in geometry. Then select the 3 points for the plane icon for define mirror plane normal. Select any 3 points that lie in the plane figure. And make sure the reverse solid box is checked. In this case, we need to turn on auto execute. And then select all the solids. Now we're going to create group hex 20 and copy geometry into it. We're going to make a click in group and then select create. Enter hex 20 for new group name and click apply, then cancel. Now make sure the transform solid and translate are selected in geometry. Enter 5000 for direction vector and select all 10 solids and then click apply. Now we're going to make a click in group and select post. We're going to make a click and select all, then click apply and then cancel. Specify front view and click fit view icon. Reduce size of point makers and on display solid labels. Now we're going to create coordinate systems. We're going to make sure that create chord and 3 points are selected in geometry. In time, we're going to select cylindrical and select 3 points as indicated. Remember to turn auto execute off. Then we're going to make a click and apply. Now we're going to add some mesh groups hex 8 and hex 20. Make a click in group and select post. Select the hex 8 group and then click apply and then cancel. We're going to make a click in elements and make sure that create, mesh and solid are selected. Select the hex, isomesh, and the hex 8, or remove check for automatic calculation and enter 0.5 for global edge length. Now we're going to select the hex 8 geometry and click apply. Now we're going to repeat the same steps, but posting the hex 20 group, selecting hex 20 instead of hex 8 for the topology and applying it to the hex 20 geometry. Now we're going to TED-mesh group TED4 and TED10. We're going to make a click in group and select post. We're going to select the TED4 group and click apply and then cancel. We're going to make a click in elements and make sure that create, mesh, and solid are selected. Select TED-mesh, and TED4. Then we're going to select the TED4 geometry for the input list. Remove the check from automatic calculation and enter 0.5 for global edge length. Then click on Assembly Parameters and click on Match Parasolid Faces. Select at the TED4 solids again. Now make a click in Close and then in Apply. Now we're going to repeat these steps by posting the TED10 group, selecting TED10 for the topology instead of TED4, and applying it to the TED10 geometry. Because we have the student version, the software doesn't let us do this step, but at the end of the video I'm going to show you how it should be. Now we're going to click in group and select post. We're going to select all 4 groups, click apply and then cancel. We're going to make sure that verify elements and boundaries are selected in elements. We're going to click apply. Then observe the free element chances of meshes. These can be easily remined by equivalence in meshes. Now we're going to make sure that equivalence all on tolerance cube are selected in elements. Then we're going to make a click in apply. Then make sure that verify elements and boundaries are selected, and then make a click in apply. Now we're going to copy coordinate systems. Now we're going to make a click in geometry and make sure the transform chord and translate are selected. We're going to enter 15, 0, 0 for direction vector and select chord 1 for coordinate frame list. Remember to turn auto execute off. Then click apply. We're going to repeat these steps to create chord 3 and 4 using 0, -10 and 0 for the direction vector. And selecting both coordinate frames, chord 1 and chord 2 for the coordinate frame list. Now we're going to create fields for loads BCS. I'm going to make a click on a smooth shade icon and make a click in fields. Then we're going to make sure that create spatial and PCL function are selected. Enter seat pressure hex 8 for field name and select chord 1 for coordinate system. Then we're going to enter the next name for scalar function and then click apply. Now we're going to create 3 more fields by repeating the steps. Now we're going to make a click in loads BCS and make sure that create pressure and element uniform are selected. We're going to enter hex 8 for new set name and click on input data. Then we're going to enter 1000 under load BC set scale factor. And under pressure select Sign pressure hex 8 from spatial field. Then click on OK. Then click on select application ratio and shift click the 4 faces as indicated and click add. And then click OK and then apply. We're going to repeat the previous steps for the remaining 3 pressures, zooming in one each model as needed. After all 4 pressures are created, click the feed view icon to show all the models. Now we're going to make sure that create displacements and nodal are selected. Enter constraint for new set name and click on input data. Then we're going to enter 000 for translation and then click on OK. We're going to make a click in select application ratio and click the surface or face icon. Shift click the back faces of all the models. Click ACK and then OK. Then click on OK and apply. Now we're going to create material and element properties. We're going to make a click in properties and isotropic. We're going to make sure that create isotropic and manual input are selected. We're going to enter aluminum for material name, and then we're going to make click in input properties. We're going to enter the following values for the elastic modulus and position radio, respectively. Then we're going to make a click on OK and apply. Now we're going to make a click in solid and make sure that create 3D and solid are selected. We're going to enter solid for property set name and click in input properties. Click on Matprop name icon and select aluminum, then click OK. For application region, select all solids and click Add. Then we're going to make a click in OK. And then in Apply. Now we're going to check the load cases. We're going to make a click in Load BCS and make sure that Modify is selected. We're going to make a click in Load Cases and select Modify, Then click on Load Case Name Default and make sure that all loads and constraints are listed. Then click Cancel. Now it's time to run the analysis. We're going to make a click in Analysis and make sure that Analyze, Entire Model and Full Run are selected. Then we're going to make a click in Translation Parameters and then in OK. Now we're going to make a click on Solution Type and make sure the Linear Static is selected and click OK. Then we're going to click Apply. We have to wait just a second for the analysis to run. Now we're going to make a click on Analysis and access results. Attach XDB and results entities are selected. We're going to click Select Result Files, and we're going to select log.xdb and then click OK. Then we're going to click Apply. Now we're going to make a click in Results and make sure that Create and Deformation are selected. We're going to select Displacements, Translations, and then click OK. Click on the Display Attributes icon. Remove Check from Show Underform and Show Title and then click Apply. Now we're going to make a click on Plot Erase icon. And click Erase under Geometry and then click OK. Then we're going to make a click in Results. And a click on Fringe. Then we're going to make sure that Create and Fringe are selected. Select Stress Tensor and Von Mises and then click Apply. Now we're going to read and display the analysis results. We're going to make a click in Menu, Viewport, and select Modify. We're going to make a click in Rename and enter X8 under Rename As. We're going to make a click on OK and then Apply and then Cancel. Then we're going to click on Viewport, Create, and enter Hex 20 and click Apply. We're going to repeat this step for creating viewports TED 4 and TED 10. Then click Cancel. Now we're going to read and display analysis results, and we're going to make a click on Displays and we're going to select Current Frames. We're going to select Unpost All and click OK. We're going to select the Hex 8 viewport by clicking on it. And then we're going to make a click in Home, Group, and then Post. We're going to select the Hex 8 group and click Apply. We're going to make a click on the Fit View icon. And we're going to repeat these steps for the remaining viewports, selecting each one and posting their corresponding groups. Cancel from the group dialog. Then we're going to make a click in Results and make sure that the Create and Deformation are selected. Select Displacements, Transitionals, and then click Apply. Then we're going to make a click on Fringe and select Stress Tensor and Von Mises, then click Apply. We should repeat these steps for the remaining viewports. This is how the loads and boundaries condition look in the 4 elements. And this is how the read and display analysis results look in the 4 elements. Here is the form shape plot with the von Mises stresses. And here is an illustration of the 4 tile viewports with the corresponding model and resource, each having a maximum stress value indicated. Well, that's all for this video. I really hope you like it. Don't forget to give me some thumbs up and go check my other videos. Bye!